Hello, this is Laura Rebelke. I'm a Principal Program Manager, or actually a Principal Software Development Engineer. Sorry, I'm with a great host of program managers with me today, but we're going to be talking about Azure and building great apps on Azure. Thank you for joining. Please do be sure to submit some questions. We're really anxious to answer your questions. But before we get started, what I'd like to do is just introduce the panel and give you a little taste of the kind of people that we have here and the things that they want to talk about. So we're going to start with Yohei.
Hey, thank you, Laura. So my name is Yohei Kiryadi. I'm a Principal Program Manager lead at Microsoft, specifically working on Azure. And within Azure, I work on a service called App Service. I've been working with the team for over 5 years now, so kind of from day zero of the service, so we build it all together, which is really cool. So App Service is probably the easiest way you can start with Azure today. It takes about 30 seconds to create a web app or a mobile app, and then whatever you have, any kind of web app that you got, you can just deploy it over there. Whether it's obviously .NET, but PHP, Python, we even support for Go. And it just runs. You don't really care for anything else in terms of the infrastructure. But it can also scale very much. Recently, we have supported some fairly large election that happens somewhere. So
Okay.
we scaled. I don't know if we can say that or not, but we scaled to like 1,300 VMs and cores running this app across web, mobile,
Very
all
nice.
sort of devices. So it's very super easy to start and very cool to scale. We made several announcements in the last couple of weeks. We have App Service includes web, mobile, logic, and API. So we have enhanced the mobile capabilities. It's now just part of an extension of the web, so you can host both at the same place. Very nice. And a similar way, we did the updates for the API as well.
Excellent.
There'll be a new release coming out in actually a matter of weeks now.
Fantastic.
And a couple of weeks ago, we also announced general availability for App Service environment, which allows you your own full dedicated deployment of App Service, which is super cool.
Very good. Very good. Well, looking forward to talking more about all of those services. Thank you.
Sure.
Thank you. And we also have Tony Petrosian. Tony, talk to us about who you are and what you've been working on.
My name is Tony Petrosian. I'm with Data Group at Microsoft. We have a lot of Azure services, including Azure SQL Database, Document Database, Azure Search. We have Data Lake. So we've announced a lot of stuff, plus our HD Insight. We recently announced that the GA of HD Insight on Linux, which is very exciting for us. So on the SQL DB side, we have recently announced a preview for global transactions, global queries. Our Elastic pools now support a lot more databases, a higher density. So a lot of excitement there. And so we can talk about all these things. Hopefully people will have lots of questions about search, document DB, SQL DB, and bring them on.
Data.
Yeah, data.
Things have been moving fast.
Yes, things are moving fast. It's a very exciting space for us. And
It is.
A lot of changes.
Great. Thanks for joining. And Mark Fussell. Talk.
Yeah, so my name is Mark Fussell. I'm a program manager that works on the Azure team. I work on Azure Service Fabric. Earlier this year, we announced Azure Service Fabric at Build. And there we provided you with an SDK that you could download and build applications on your machine. Service Fabric allows you to build these high-scale, we call them sort of born-in-the-cloud services, high-scale, low latency, very focusing on the sort of stateful compute that we have inside them all. And we very much think of this as a way that you build services that we call, decompose them into what we call microservices. So you can break down this service into smaller pieces of code. And the whole microservice concept, which is kind of gaining some traction, is about how you can build things that run at scale. But it's also about agility, about how the fact that your service that you're running evolves over time. You can add new services, take them away, and generally evolve it as your customer demands. And so it's the agility of that. And a lot of the teams inside Microsoft have sort of transitioned this way. We use Service Fabric heavily inside Azure for the core services themselves. And we built a number of big services ourselves, such as Intune and DocDB and a number of other services. And yesterday we were thrilled because we actually announced the public preview of Service Fabric, which means now you can take your applications that you built on your dev machine and host them and run them inside Azure. And so you have all the benefits of running it in a hosted environment inside Azure. And we're super excited about this. It's been a long time coming.
And the SDK.
And the SDK, we
Right.
refreshed the SDK. There's
Huge.
new things inside the SDK, new features, and I'm going to give you some demonstration of what that looks like.
Well, why don't you go ahead and give us that demonstration?
Okay.
We'll just jump right in there.
Let me just pop this over here. Let me go up onto this desk up here. I've got my... You should hopefully be able to see here that I've got Visual Studio. There we are, displayed. Now, what I'm going to do is I'm going to show you how you build your first Service Fabric application inside Visual Studio. I'm going to do File, New, Project. And inside here, you'll see that Service Fabric comes up as part of the cloud templates. I'm going to select Service Fabric. I'm going to hit OK. And here you'll see that there's a choice of different types of programming model that I can use to build. We provide you two out of the box. We build this one called Reliable Services, which you can think of as exactly the same as cloud services. You're familiar with that with worker roles. We also provide this one called Reliable Actors. Scott Hanselman showed a great demo yesterday of using reliable actors, where he showed how each one of these actors was an individual patient. That patient had a band associated with them, with that data, and you could scale out hundreds of thousands of actors across a set of machines. So we're seeing that this fits in very well with a lot of cloud scale applications. The third thing you could also include as part of your application that you deploy in Service Fabric is ASP.NET 5 to build web front end. So we're thrilled to be able to support that as a first class. So I'm going to select a stateful service here. I'm going to hit OK. And what it will see is it'll generate me a project that contains an application and a service inside this. And this service, you'll see that each one of those services is considered to be like we think of them as a microservice. So if I just zoom in up here, you'll see that I have a single application here. And I have a single stateful service inside here. And I can go inside here and I can add many more services to my application. So I can have 10, 50 services as part of all of this. So what I'm going to do now is let's just briefly look about what the content of this stateful service looks like. Because here's the interesting thing. If you build cloud services, you'll be very familiar with the fact that this just has a run method here. So it just starts a piece of code. The interesting thing about this stateful service is what we have is this reliable dictionary here. And what we've done with Service Fabric is that we've sort of taken a natural evolution of the collection model that you have inside .NET. You had collections, you had concurrent collections, and now we have this concept of reliable collections and a reliable dictionary. And what this does is it democratizes HA. It gives you high availability and replicated state for that dictionary. So you'll take that code and state and replicate it onto other machines. And this now allows you to provide this really interesting types of designs where you can have the state and the code co-located, knowing that your state is highly available and your code is close by, so you can do these high throughput, low latency scenarios. So I'm just going to hit F5. I'm going to build and deploy this to my local machine. On my machine here, I effectively have a 5-node cluster running. This is the same as if I had 5 nodes running inside Azure. PowerShell is used to package and deploy all of this. And it runs on my local machine. And what you'll see here is it'll start up. I'll see a set of diagnostics events happen inside here, and I'll see the diagnostics for this particular service running. This particular service just as a simple counter. It just starts counting through and putting a number inside that reliable dictionary. And soon you'll see some counter events that come through here. Here it is at the beginning. Here is just the counter starts through its different values here. The great thing about this is you want to be able to visualize this more. What we have is built in as part of the framework. We have this concept of a Service Fabric Explorer. This allows me to view the applications I have and the nodes that are running on my machine. So here I have on my box a 5-machine cluster. Think of this as exactly the same code as if I'm running in Azure. And here I've deployed that application we've just seen. You'll see that here's that application type 1 that just got deployed. I can drill into this deeper. But if I drill into this deeper, I can see that here's the instance of it, stateful 1. And then if I expand it out entirely, you'll see that that actual stateful service has had its code deployed onto node 2, but secondary backup copies of it on node 1 and node 5. So that's the high availability replicated state across these set of machines. And what's so great about this is that I can build applications and know that if I have failures, so if, for example, in this particular case, the primary is running on node 2, I can actually go into the tool here, I can shut down and deactivate node 2 on this particular machine. And when I do that, Service Fabric has all of the intelligence to say, what I need you to do is fail over to one of those other replica copies we have. And so what you'll see is that we'll see that this primary now is failing over from, instead of failing over from node 2, it'll fail over to one of the other secondaries. And you see here now it's failed over, the now primary has moved to node 3, and I've maintained all the high availability of my state. If I return back to my demo here, you'll see that the counting of these numbers as it goes up here had a small little bit. I'll just hit F5 and continue here. And you'll see a small little blip while that failover happened, but I didn't lose any of my state during that failover. So this allows you to build these high available, high throughput services and deploy them on a local machine. But what we announced yesterday was effectively I can take that and I can run it in Azure. So here, if I move over to the portal a moment, you'll see that here I've got a cluster of those machines that I've now deployed in Azure. And what's great about this service is that we fully manage all of the runtime bits on that cluster for you. You have all the control of the VM, but we'll come along and patch all the bits of Service Fabric running on those machines for you. So what I can do is I can actually now open up an Explorer here and see if I go and look at this particular view of the Explorer running in the cloud, you'll see now I have a different URL address here. You see I have a cluster here that's running inside the cloud. Same thing now here, if I open up and look at the nodes, you'll see now they actually are physical machines with IP addresses here. You've got the failure domains and upgrade domains. I can see a view of my applications that are deployed here as well. And what I'm able to do is I can actually go and take this URL here. I'm able to go back into Visual Studio. I'll just stop debugging here a moment. And inside Visual Studio, we have a first-class experience of deploying that same application to the cloud, node code changes. If I just go up here and see that I have some published profiles, you'll see that I can expand this one out. And I have a cloud profile here. And I can simply put the connection point here to the actual cluster I have running in the cloud. I'm going to provide a URL to connect to. Now I can simply do right-click, publish, and now you'll see that I can choose, instead of going to my local cluster, I'm going to deploy to the cloud. So I'm going to hit publish here. Same PowerShell commands, same code, packages, deploys, and it'll push that up into this cluster here running in the cloud. And what we'll see here in a moment is that the number of applications here will go from 2 until 3. There it is. I can now drill down into here, and you'll see that that same application is now deployed and running inside Azure in that hosted public preview we'll provide you. So this is a great example of now no code changes deployed to the cloud. I'm running here, and it's just a different cluster in a different environment. And we'll see in the new year how we'll provide the same download you can run on Windows Server, so you can deploy on Windows Server on premise. And just to finish off, just to give you this concept of cloud services, I just want to kind of show you one more example of where, here's an application now, and it consists of more than one service. Here it consists of a web application, an ASP.NET 5 application, and we also have sort of a back-end service here. I've used a controller here, a web API controller, to take in all my requests. And then here, those requests get pushed through to a service that's running at the back here that contains a reliable dictionary here of all my messages. And here I'm doing just a reliable dictionary of date-time messages. And what that looks like is an application that I can run here locally, where I can show a list of messages. It's like a chat window. I can push messages. We can even have messages for this forum posted up here. I can type in, this is a new message here, and I can send this. And here I have the benefit of, a web application deployed in here and a back-end service running reliably. So, that's an example of how we use this.
Thank you very much. It's a great demo. It's a really great story too, and
it's a fabulous story. I mean, we're finding that we have lots of customers. In fact, in our preview program, we have over 300 customers as part of our public preview. A lot of them are trying to go actually have launched early services with their customers that they're running. We've been using Service Fabric internally to build services like Intune, DocDB, Azure databases for a number of years.
Yep.
What's evolving for us is some of the programming models that sit on top of that. The active programming model is turning out to be very powerful for people.
Yes.
We have a great customer in our program called Schneider Electric. Mm-hmm. Schneider Electric do energy and device management. And they're trying to provide a general purpose platform for managing devices. And they found that the actors greatly represent the devices that they manage. They can have a set of machines, deploy 10,000 of these actors, and be very agile in how they develop their service, scale it all out. And there's a very good relationship there around those two. So yeah, we're having great feedback from a lot of customers, and we've built we're thrilled that next year we'll be able to take this to GA.
Right. Great, thank you. And there is a question, just to follow up on this, from one of our watchers out there. Where can they go to find out more about and learn more about microservices? What would you recommend?
Well, we've just published some documentation yesterday. So if you go to Azure site and you look up Service Fabric, there's some great documentation we provided inside there. If you do some search across the web, there's been some great articles and books published generally. I mean, the way to think about microservices is it's a design principle that's evolving. There's some well-known people have published some articles and some books over the years. So I would just encourage you to search on the web, and you'll find some good stuff about that.
Great, thank you. Thank you. We have a lot of questions that have been coming in, so please continue to feed the questions. And what I'm going to do is just start to pick a couple of the questions and ask our panelists. So we'll start with data. We've got a couple of data questions in here. There are a lot of different data services out there, and I hear this quite often. I engage with a lot of partners who are building SaaS applications. And the big challenge for them is there's an overwhelming number of choices. So how do you choose between SQL DB or DocDB or data lake or data warehouse? What are the design principles you look for?
Yeah, so, of course, one of the things that drives a lot of choices is preferences. So we always want to provide our customers with all the preferences, all the choices for whatever they prefer from a building application and the models for it. But in general, if you have transactional or relational workloads, SQL DB does really well. Things which are schematized. So applications that have a well-known data format and data structure, and you truly need the relational capabilities. SQL DB is a great thing. If you have data which is with no schema and you want flexibility and you want to just start writing code in a code-first model, then DocDB is a great thing. If it's an excellent JSON store. So for example, if you're building an application like Mark just demoed, and you have all these messages and you want to persist the messages for historical purpose, you can just shove them into DocDB, and then over time the format can change because it's just JSON, right? And there's no schema to it. So DocDB works really well in situations like that. It's a very scalable store for that. And of course, for data warehousing, if you have a traditional data warehouse like SQL data warehouse is a great choice. And the thing about SQL data warehouse is, again, you can have a schema, you can build your structure, you can build your indices, and you can put a dashboard in front of it, have sub-second query responses. So again, when you have well schematized and known data, historical data, the data warehouse works well. Moving to data lake, again, if you have lots of data and you haven't figured out what the data is about. So in the case of lots of IoT scenarios where you just have vast amounts of data coming in, and over time the shape of the data is changing, and you don't exactly know what the insight is that you want to get, but you need to capture all the data. And then you can run large analytics on top of it. And data lake works really well because you have this separation of storage from compute. So in our data lake, you have an HDFS compliant store, and you can just basically write all your data in there. And then you can come back and use languages like USQL, which allows you to run SQL and C# code against the data to
or
actually...
Or even HD Insight clusters.
Or even an
Absolutely.
HD Insight cluster and run Hadoop. So these are all the various things that drive the decision and the choices for the customers.
Great. So I'm going to give one more question from our audience, and it's Skyonics, I think, is how the handle is reading. There's a lot in Azure, and it's really hard to keep up. And they're asking, are there any plans to help make it easier and give you focus on what you need to get started? And I'd actually ask you this question, because the web apps and websites, it seems to be the place where a lot of people go to get started in Azure. Would you like to talk a little bit about the getting started experience that you see with a lot of our customers?
Sure. So yes, Azure is big now,
Yeah.
right? If you look at some of the slides they showed yesterday, there are about 59 or 60 icons over there, which represent 60
Yeah.
services. So it's going to be a little bit overwhelming. And yes, there's a lot of things you can do. There's a lot of options there, but if you want to very easily create any sort of web experience or a web APIs or mobile experience, app servers provide you a very easy way to just create. You don't need to worry about managing VMs because the system is doing it behind it for you. We are owning and managing those VMs for you. We're managing the frameworks, managing everything that comes with it. So what you get is basically signing, not really a container, but kind of a box in which you can deploy your apps and they just run. So
from developer operations support, continuous integration, how do you start going to that next level then? So you've created your websites, your apps, and how does that start building into some of the tooling and the support that people need ongoing?
That's a great question. So it's super easy to start, as I said. If you have an ASP.NET, you can FTP it and it will just work probably,
Right.
PHP or anything like that. But we also provide support for continuous integration. So obviously we integrate with Visual Studio team services, whatever the new name is. And we provide that integration. So you have continuous integration with Visual Studio. You obviously can do GitHub and Bitbucket.
Right.
We provide that, so anytime you can push, you can integrate your continuous integration. We also added some other features for the DevOps that include, for example, staging environments. So you can have any number of staging environments that are actually related, they're all bound together. And it's very easy to swap in between, and you can imagine you have dev, test, QA, stage, and production, and you can slowly move between them. Obviously, you can automate it with Visual Studio Release Manager. There are separate APIs, you can do all of that very nicely and easy.
Great. And do you have a recommendation, someplace to go learn more and get started?
So Azure.com is probably the best place to start. There are getting started for each of the services, and there are what we call a learning path. So if you go to Bing and do Azure and basically look for Azure Learning Paths, then you'll be able to.
The learning paths are very helpful. Yep, I found that too, and I know we've got that one in data as well, and very nice documents. Excellent. We had another question that was related to, and just going to find out, the Service Fabric. Can you, and it's from Nick Burr, can you give some more customer examples of how they use Service Fabric and what are the problems that they're trying to solve? I hear this a lot. People are still trying to get their head around this, trying to apply this new Service Fabric to this existing world or the past world, and they just can't seem to figure out, why would I need this?
There's a lot of I think a lot of trying to understanding what's happening. I mean, what we've noticed, and it's sort of Microsoft went sort of the same transition itself, is that we had this lift and shift scenario realm where people took existing applications that they built on premise and they moved them into VMs running inside Azure. And a lot of the designs that you thought about at that time were referred to as sort of monolithic in a sense, where you had a sort of a database tier, we had some business processing logic, and we sort of had a front end. And they were very well factored, but they were sort of factored into tiers of logic. And what that enabled you to do was very productive in terms of creating those sort of apps. But when you actually hosted them inside the cloud, scaling individual pieces of that and scaling up was a harder thing to do. Plus, it was sort of less agile because you had this sort of single tier of components that you had to wait for everyone to ship together. Everyone had to test together, everyone had to build together, everyone had to ship together. And moving to the cloud really just means that developers now have to think about how things scale and be more agile. And so what we noticed is that, and a good example of is a company in the UK called TalkTalk, who do a service called Blinkbox, which is a video on demand service. They actually they run on Azure today, and they moved over an existing IaaS implementation, and it runs very well. But since they've been acquired by TalkTalk, their growth has exploded. And what happens today is that they need to, for all of them to do updates, everything's tied to a database that they have running inside a VM, and it means that they have to have some downtime. And they want to yet push features more quickly than this. So they've actually been teasing off little pieces of this existing application and building them as microservices first, just to give them agility in particular parts. So for example, they have an encoding service that takes in media streams, it encodes it for particular devices. And what they found was that they took this encoding service, they used Service Fabric to do the schedule of the encodings. They actually integrated with Azure Batch to actually do some of the encoding algorithms, and then pushed this into Azure Media Services that they could serve it up through there. and actually used API management to service that API out. And so people are finding that they're taking these existing lift and shift applications, but because of the needs to be more agile and because of some of the scale of different areas, the microservices concept of breaking these things apart really is where it comes into play.
That's really the beauty of the cloud, having that elasticity and that agility to scale in, scale out as you need.
Yes, and so the way we think about Service Fabric is actually you can deploy any pieces of code. So we provide some out-of-the-box runtimes, that reliable service and actors, you can use those. But if you want to deploy MongoDB or Cassandra or other say Node.js or other programming frameworks, you can build it all with those as well, and it helps you just deploy those across a set of machines. So it's a very flexible framework. It means you have a little bit more control and there's a little bit more work in order to do that, but it allows you to sort of have these services that are sort of decomposed down, deployed, and Service Fabric takes care of all of the failover of your code and the deployment of it. And importantly, most of the cost of running a service is in the management of it, the versioning, the deployment, upgrade. So that's really where the microservice concept comes in. How do I independently version, upgrade a piece of code while other people can keep working? This team can do their work, and that team can do their work, and they can do them at different times.
And I hear this theme over and over about you start with the lift and shift. We've got an app, it's been running forever, sitting in our data center, and we're going to bring that up to the cloud. And yay, we're in the cloud now. But they really don't have all the benefits of the cloud. And so, this actor model is that next step. As a follow-on question, this is for Tony. Somebody was just asking, what are the differences between SQL Server and Azure SQL Database, which then also leads into we start with a SQL and a VM. And when do you start thinking about, it's time to maybe use the service?
Yeah, so the latest version of Azure SQL DB, we call it V12. From a programming surface area, it's pretty much the same as SQL. It uses the SQL 16 engine.
SQL 2016, which isn't even GA yet.
Yes.
So we're running that in production.
We're in a cloud-first development model, so everything goes to the cloud first before it makes it to the box.
Yep.
And so from a programming perspective, it's the same. And we have a lot of customers, we've been around for 6-7 years now, and customers who just basically, as Mark was mentioning, lift and shifted their app. So they have a database, they put the database in a VM, and that's where they run it. And then they have to manage the HA, they have to manage the disaster recovery, they have to deal with all kinds of things that happen. So slowly they decompose their app and go, okay, I'm going to take that database part and just put it in Azure SQL DB because that simplifies and I don't have to manage the HA anymore.
Right.
So that's a very natural thing. And we also have a lot of customers who basically are cloud-born. And they're not interested in managing VMs. They're not interested in managing an instance of SQL, so they go to SQL DB.
Right.
We have customers who are using lots of frameworks to build their application, Django or Rails.
Right.
And it's a lot easier to just basically point to a database and you don't have to
give
manage
me a service.
Yes, give me an endpoint and I want to
put and get data.
SQL to it.
You take care of the rest.
Yeah, we take care of the rest.
And you take care of a lot of it too. The point in time restore is available, geo-disaster recovery.
Yes, you can.
Very nice.
We have data protection services and everything. And one of the differences that exists is basically with SQL Server, you have a management surface area to manage the instance of SQL. And with SQL DB, you don't have those because you don't have to deal with it.
Right.
But there's no always on because we manage the availability. We give you 4 nines.
Right, right. And you're actually using a lot of telemetry to make sure that you're constantly learning and
Absolutely.
and understanding new ways to manage those services.
And we use Service Fabric to run SQL DB. So thank you, Mark. It works pretty well, and because we use Service Fabric, we do have these microservices. So we have all these agents that run alongside the SQL engine within Service Fabric, and so we're able to extract telemetry. We run the telemetry through machine learning facilities to figure out recommendations for customers, like if they're missing an index, you get a notification that, hey, maybe you should build an index to optimize your workload. So that's kind of the next level that we take this stuff.
Excellent. That's all part of being a service.
Yes, that is what service means. Yeah.
That's right. We have another question. This is from Eduardo Quintana, I believe. What's the most cost-effective way to create a lot of small sites on Azure? And he's asking, should I just create a virtual machine? So when you're looking at some of these, I've got a whole bunch of websites or small sites I want to create. what's the best way for me to manage that from a cost perspective? And we hear this a lot with partners, building out SaaS applications, right? So what would you recommend?
So there are a lot of options. Obviously, you can go with a virtual machine, and he can run either Linux or Windows machine and host and manage. But then he has to, on top of managing the VM itself, and I think Scott Henselman gave the analogy of a puppy yesterday, which was pretty good.
It was funny, wasn't it? You have to keep updating the puppy, I think he said.
I'll use that moving forward. Thank you,
That
Scott.
was funny.
Yes. So beyond have to take care of your puppy, which is a Linux VM, now you need to make sure that you get deployed apps, and you need to update deployed apps and all those. So you need to mechanism to build this. And if you want to run at high scale, or if you want to run more than one VM, if you have a lot of sites and you need to eventually grow and you need to manage all of that on your own, certainly doable. But if you go with a service like app services, then basically all of that is being given for you.
Right.
A web app is a logic entity in which you can just deploy and just you point it out. And if you have a lot of density, then we basically make sure we take care of the load balancing for you across multiple VMs, and all of the high density aspect of the hosting is taken care of.
Fantastic. Fantastic. Sounds like a really compelling service for, especially if you're trying to manage a lot of small sites.
Yeah, definitely, because for each site we provide all the monitoring capabilities.
Yep.
So obviously, beyond just the logs, you have all the monitoring. We integrate with the Azure App Insights.
Right.
So you get app implication insights. You can have alerts, rules being triggered automatically. You can actually, we just added the ability to add webhooks. So when everything happens, you basically get a hook and you can act upon this. You can send emails, you can scale, you can move the sites in between, so you can have maybe some larger site be scaled out separately than all the other sites.
Great.
So very manageable.
Great. We had another interesting question, and it's from Rajiv, and I hear this a lot. And he's asking, will Service Fabric support containers? And the other question that I often hear that's along the same lines is, can you talk to me about containers versus Service Fabric? And so there's a lot of these new microservices and containers. So can you talk a little bit about?
Yeah, so I mean, containers is a great technology that's kind of emerged over the last few years. And containerization, I look at it as the next level of virtualization. You can put things at higher density on a set of VMs, and inside those you can place your applications and run them. And those containers allow you to deploy and manage the set of applications across them all. On Linux you have Docker containers. We talked about when launched Windows containers that run on Windows Server. And Windows containers allow you to also load up those Docker images. Where it fits in with Service Fabric is that it's actually, it fits in very seamlessly in the sense of Service Fabric is about deploying applications across a set of machines. When I showed you in that demo there, it deployed an application and it launched it across a set of machines and just activated the processes. Early next year, you'll see that we'll do a release of Service Fabric that will actually launch those processes, but activate them inside a Windows container, inside Windows. And so what that gives you is that gives you all the resource constraints for running those processes inside that container. So you can manage the network or manage the disk and constrain the resource inside there. So you have all the benefits of just saying in the declarative model, launch this inside a container. But the failover still happens for the application in terms of how, when the machine fails, I'll move my application to another machine, activate it inside a container there. So, you have this choice of this integration inside there. And then as we look towards taking Service Fabric to Linux, that will launch next year, we'll of course do the same thing there, running Service Fabric and activating Docker containers there. And so you actually have exactly the same benefit of running with containers inside Linux. We also in Azure earlier this year launched and talked about a container service. And that was to help us show that we could, we launched Mesosphere. As a container service that's going to be that will be running inside Azure that launches Docker containers there. So the way I look at containers as this way of managing an application you can deploy across multi-machine. You can just bring along your code and just use the container framework for deploying them. but quite often you sort of want to up-level that to the actual application itself, whether it's a web application or some other application. And so that's where sort of Service Fabric kicks in terms of providing those high-level programming models that integrate with those containers. So hopefully there's a nice story there of the containers being where you can run your code. You can just use containers themselves and just download a Docker image if you want to just run that, or you can sort of take advantage of the out-of-the-box programming models that just help up-level how you do your designs and run them inside those containers.
Right.
And it makes it for a very compelling story, because those containers help do the sort of higher density resource constraints of what you run inside that VM.
Great. Thank you. We also have a question around machine learning, and I work with a lot of partners who are doing interesting things with integrating machine learning within applications. And you talked a little bit about some of the things that we're doing using machine learning. Tibaram, and I apologize if I'm butchering all these names. I'm very bad at names. If you can talk a little bit about Azure machine learning, and what are some of the possible scenarios that you've been seeing with customers where you're engaged, or what we're doing with it?
Yeah, so there's a lot of cool technologies in that space. We have some demos that are really fun to play with, like there's a howoldiam.net,
yes,
where you can go and you take a picture and then it'll guess how old you are, and it uses the machine learning algorithms. It's actually a good place to go to get started, because it points you to some interesting scenarios. Yeah, and it gives you the code, so it's a good place to start. Internally, we use a lot of machine learning. As I mentioned, we run all of our telemetry through machine learning. We have things like Spark, if you want to, in Hadoop, if you want to run a stream of data that is coming in from wherever, and run it through machine learning algorithms to classify things. So for example, we did a demo not too long ago where you're taking comments being made by customers of yours about your products, and you run it through classification to figure out if the comment is a positive comment or a negative comment, and classify them. So imagine if you sell a product, and people go and talk about your product on Twitter and say, hey, this product is great, or the product is missing a feature, or whatever. And then you're never going to have enough people to sit there and read Twitter comments and categorize them and analyze them, especially if you're a large company.
It's overwhelming.
Yeah, so you could use machine learning, and there's a lot of code already out there, so you can just go pick up a existing classification code for classifying comments and take the benefit, and then you can actually act on this insight. You run it through Spark, you classify them, you figure out what people are saying, and you send it to the department that is responsible for whatever particular thing people are happy about or complain about. So those are some of the really interesting, and the Azure services makes it really easy to do this, because you can collect the data, you can stream through it, you can store this historical stuff in DocDB, for example, and so this is what people are doing today.
And the really great part is that even just a few years ago, doing things like streaming, the barrier to be able to stream and apply calculations in a stream of data was huge. You needed the skills, you needed the hardware, you needed the software, and it just was those were not commoditized. And now in the cloud, in Azure, we've got these as commoditized services. You can spin it up and have a stream of data actually end to end. I do these in demos, 4-minute demos, end to end, doing streaming calculation. And I also find one of the great compelling things about Azure Machine Learning is it's highly customizable. You can go in and build your own models, but we've also got sentiment analysis models out there. If you want to just hook into those models and say, I want to just integrate a web service API call to an existing model in the cloud and bake it in my app.
Yeah, and that's really the big benefit of being able to just capitalize on work that already exists.
Exactly.
You can go pick up our scripts, bring them in, and run it, right? And there's so much out there, and there's marketplaces for this stuff.
Yep. And if you want to customize it later,
you
can certainly do that.
We've picked up some of the scripts.
You have?
Yep. So we baked some of the machine learning into the system. So other than
what kind of things?
Other than helping us, we are surfacing what we call recommendation now to the users. So if users, for example, deploy a lot, but they're not using the advanced deploy features, so they might be ending up with reducing their SLAs or having downtime or whatever. So we offer them, hey, why don't you use this? And a more interesting aspect is we looked at the runtime characteristics, CPU, memory, disk utilization, and if they're doing something offensive, Then we provide them, hey, on average, this is what you're using. You're using too much this day on that
Yeah.
day. And we have features like auto heal, which will actually understand and figure out, hey, if you're in a bad state, we'll restart you, or they can memory dump and put it in the storage for use,
Yeah.
for later use. So
It's really
we've
great.
been enhancing the service with that.
Yep. Again, all part of that service.
Yes.
Terry had an interesting epiphany. It seems like Service Fabric ultimately replaces legacy cloud services.
Yeah, this is a great question. This is a question we get all the time. You know, what's the relationship between Service Fabric and existing cloud services, web and worker role, and what does it all mean? Well, first, cloud services are not going away. We're going to keep that around for a long time yet because it's heavily used. We use it internally to build many of our services today. In fact, large numbers of Microsoft services run on cloud services today. So keeping all our services going requires us, for keep cloud services there. But what we found when we started to build some of the, more recent services is that, particularly there were three problems that we had. One was deployment times. Today you have a single application in cloud services that's deployed inside a single VM. And so when you want to do any configuration changes or code changes, you have to recycle the whole VM. So one of the key things that happens with Service Fabric is you separate out the infrastructure, the cluster of machines from the actual code itself. Mm-hmm. So you have this environment and you can have this pool of machines now. And you can have 5 machines, you have 10 machines, you can have 50 machines. They can be of any sizes as well. You can have some D series, you can have some A series inside there. And Service Fabric also knows about all the available resources inside there. It knows the amount of memory, the amount of disk, right, everything that's used. And so you get this agility now of building this application package. And as I showed in the demo, it does a fast package deploy, pushes that out onto those pool of machines. And so you get this rapid development of just pushing out and deploying services much more than cloud services. That was one side of it all. The other side then is just the fact that you can run things at higher density. What we observed with cloud services is you get a lot of small A2 machines, and people stamp out lots of these ones because they had a service that just did a piece of work and all they needed was the smallest VM to run it in. But as your service grew larger and larger, you still had to have lots and lots of these A2s. Well, you can take the same equivalent service and run it on a smaller set of machines because you can pack more services onto those same set of machines. So you get much higher density, whether it runs inside a container or just runs inside as a prone process, you get much higher density running there. So you can actually have greater utilization of your machines as a whole. And so, we've experienced this ourselves. We've taken, services that run on cloud services, moved them to Service Fabric, and just more efficiently run them effectively. And then the third benefit as well is that you can take Service Fabric and it'll run anywhere. It'll run on Windows Server. We're going to be releasing early next year the download installer, so you can take Service Fabric and run it on Windows Server. It'll be included as part of Azure Stack. Service Fabric will be built into, it's run on Nano Server. I talked about how it'll be coming on Linux in the future. So the fact that you can build this application, stand up a cluster on all these different OS's environments. You can even take Service Fabric, and if you want to host it on another cloud provider and run it there, go ahead. It'll run best in Azure, and fully recommend that. But if you want to host it on another provider, you can. So this ability to have complete independence where you run and yet have a full distributed systems framework available to you, is a very compelling one, especially where you want sort of these hybrid scenarios where you want to run something on premise, you want to run something in the cloud. You even have sort of a mixed environment where you can sort of burst to the cloud with the same bits of code. Right. So we have, this one aspect of it all really helps people kind of believe that, that's something that they can take a dependency on. And so that's how we see, how it relates. And basically, I see it as the evolution of cloud services, effectively.
Great. And it's, as you said, the existing cloud services, it's around for a while.
Yes, that's not going away, and we in Azure, we released that, when we first released Azure 5 years ago, and it's been a very successful platform, and people that continues to grow very rapidly. Lots and lots of people still use cloud services today. But as we get to GA of Service Fabric, that's another offering that we think will provide you those benefits I talked about.
Great. We had another question. So, Tony, you mentioned earlier during the introduction that we've recently released some things around distributed transactions and global queries. Can you talk about that? Because I don't know that everybody knows that this is available in Azure SQL Database.
So
these are pretty
Yeah,
cool.
so we just public preview these things. So global Elastic Query and Elastic Transactions,
Yes.
the proper name.
Thank you.
Now that it has been released. With Elastic Transactions, basically, you know, we have customers who have thousands, tens of thousands, some hundreds of thousands of databases in the system. Especially some of our SaaS providers who provide software as a service.
Single tenant approach.
Yet, you know, most of them have one database per customer because they don't want to mix data from different customers. But occasionally you need to do things to lots of databases and you want transactionally consistent activities on this. So you can use Elastic Transactions to basically run transactions across multiple databases, and you don't need things like DTC in Azure SQL DB. So,
which is where people kind of go, wait a second, I
Yeah.
don't need DTC.
Right, so you can do two-phase commit because we've built the capabilities in Azure SQL DB. So the first database you connect to, it basically takes care of your transaction coordination, and you can coordinate transaction across many databases. We also have Elastic Query. So if you want to run distributed queries across many databases, whether they have the same schema or they have dissimilar schema but same tables, you can use Elastic Query to basically run distributed queries across many databases and get the single result, right? With the proper answer, right? So this is not just a fan-out query and get the results and try to mend the stuff and put them together yourself. You actually get the proper results of the query across many databases. So with this, and we also have Elastic Jobs, which allows you to run job against many databases. These are all built for people who either have partitioned applications, scaled out applications, or even people who just want to manage schema changes across multiple databases for the same application and be transactionally consistent. So these are all great services, and so you should go out and try them.
Very cool. Thank you. Thank you. We also have a question around Logic Apps. We've had Logic Apps that was released in GA some months ago, and one of the people watching was asking, where would they use Logic Apps? There's still a little mystique around that.
Yes, so good question. Logic Apps are, to make sure, they're still in preview.
Oh, they are? I thought they were out already. I'm sorry, my mistake.
So they're in preview. The app service is part of web is GA, mobile API will be soon.
Thank you.
Logic is a great tool to very easily basically build and use APIs and connectors against data sources that you have and basically manage or kind of take care of a business entity or business logic process that goes. Built in within the system, we have a lot of API, a lot of what we call connectors. Goes out against any number of social graph like Facebook and Twitter, and also against SAPs or Salesforce. Obviously, a lot of Microsoft assets, including Office 365 and so forth, which basically very easily allow you to create a model. It's all basically big block of JSON behind the scene.
Right.
There's graphic editor, but it's a JSON behind the scene. You can hook different processes and activities together, and data flows, and take care of, in terms of running it at a very large scale, multiple triggers to enable you to enable this. And it's very easy now. Obviously, you can do it with code if you want and utilize the API, but this is just a way.
It simplifies the whole connectivity and integration from your sources, different sources.
Yep, you can take basically a lot of process or a lot of data and do transgate the data or change its format from one system to the other. If you need to include, a lot of the samples we have is we see a lot of companies that have a lot of data on premise, obviously, and they're not moving all of it out yet. But they also, some of the companies are using Dynamic CRM as example, Office 365. So now you get, or Salesforce, it doesn't really matter. Now you get data across multiple different clouds, right? There's a SaaS provider, you get the data on premises, and you need to kind of manage all of that.
Right.
So they build API tiers, and then with Logic, you can basically just connect and says, hey, there's a new customer request. So I'll put it here, part of it goes here, another one goes over there. All of that is being very easily managed transactionally with Logic Apps.
Great, thank you, thank you. Let's see, we have a couple more questions that we've seen. Some Well, this is a pretty broad question, so I'll put this out to anybody at the panel who'd like to talk about this, and maybe all of you would like to answer this one. It's from Mr. How much consideration work is needed for securing all of these cloud apps and services and machines? Big question.
Yeah, it's a big question. Security I think of security at two levels. First, there's just secure infrastructure that you trust Azure to have, the services that you need to actually, run things securely in the cloud. And then there's sort of the application security as well, and how you design application security itself. And there's things like how we integrate with Azure Active Directory, how you actually do certificate management around all of this, how you make sure that you can securely talk between the different services themselves. It's a big topic.
Yes.
So for data, we basically have introduced a lot of security features for customers to use. So as Mark mentioned, Azure Active Directory integration is where you do your authentication and the authorization. And then with something like Azure SQL DB, you can have encryption at rest, so you can ensure that your database is always encrypted, your backups are encrypted. We've also introduced things like always encrypted, so you can have some data elements, which like social security number or a credit card number, which is always encrypted, and it's never seen as plain text in the database. And we have enhanced our client drivers for SQL to do the encryption and decryption as the data passes through. And the client drivers integrate with your HSM or key management system. So only application components and people who have access to the key management will see the unencrypted data.
And that actually addresses the whole man in the middle.
Yeah, it addresses a lot of the problems.
Something a lot of people keep asking about with the cloud.
And we have data masking features. You can mask data. So we've introduced a lot of security features that, and these are features that I think are great for on-prem or in the cloud because, if you listen to the news, it's clear that the on-prem isn't any safer than the cloud. So we basically are trying to provide security features for everyone.
Absolutely.
Yeah, we're finding Key Vault as well as becoming a critical piece for people's story, where they can put all their certificates there, they can put all their secrets there, and use it as a central place. And they're using it for all their secrets they use inside configuration, rather than having it as part of their configuration and the whole management around that. Key Vault is becoming critical for storing all of that. So that's a fantastic service for keeping your secrets.
Yeah, there's another piece to it. I mean, obviously, with all the services are secure, and we go through rigorous compliance and checks and all that on a continuous basis. For example, we highly integrate with SQL in web apps, and also all the connection strings are encrypted across the board and only being open on the box when actually the apps runs. There's another aspect to that is when you deploy with Azure Resource Manager, and you can create any kind of resources, and when you deploy them, then if you create any secrets, the whole thing remains within the Azure, so it doesn't cross any network boundaries. It doesn't go into your on-prem. It doesn't actually go to your local dev box if you don't want to. So this is really cool. I mean, you can actually have a full deployment. All the secrets are keeping within the data centers, and nothing leaks out.
Yeah.
Very good.
Lastly, I would recommend anyone to go check out Azure Trust Center.
Yes.
Search for Azure Trust Center. It's the place to go if you have any questions around this.
Yes, great centralized resource for everything from security compliance and also recently we announced threat detection, which is pretty fun.
So for SQL DB now we do threat detection, which is again another component of our machine learning. Yeah. So we detect when people try to do injections and such. So you should try that as well.
Absolutely. So we're down to our last couple of minutes. What I'd like to do is just take a pass across the panel and any closing words and someplace that you would recommend people go do something first. What's the, get done with all the sessions today. If they were to put down a list, what would you recommend they should go do first? Sure.
So there is a great website called Try App Service.
Yes, there is.
And if you just go to tryappservice.com or .net, can't remember.
Okay, I don't remember.
Silly me either, yeah. But
try either.
Try either. We'll just search for them. So you land there, and if you don't have an Azure subscription, you can just go ahead and create web or mobile apps, basically, and completely interact and use them. All you need is either Microsoft account or any of the social. And you can create an experience. You can immerse yourself in it. There are templates there, so some galleries, items. You can deploy and enjoy them for a limited period of time, and we actually allow you to view some of those components within the Azure portal itself.
Excellent. Thank you.
So it's
Thank
a great place to start.
Yes. Tony.
For data, there's a lot of stuff, so Azure.com is the best place to start. When you go to Azure.com, you can go through the products or the documentation under that. There's data and analytics. Most of the stuff is there. And then you can reach us on Twitter, hashtag any of the service names, or just hashtag Azure. All of us just monitor that stuff. So you can ask questions, and we'll answer you and direct you to the right place.
Great. Thank you.
Well, Service Fabric, with our announcement of public preview, you can download the latest SDK from Azure.com if you go to Service Fabric there. I fully encourage you to download the SDK, put it onto your local dev box, build some applications. Of course, you can also now go into Azure inside your subscription and create a cluster and deploy it to there. We too have done this sort of very fun thing where we have a Try Service Fabric site. So if you go to aka.ms/Try Service Fabric, and there we've hosted some clusters for you. We actually call these the party clusters. And what happens is anyone can go up there and have a shared piece of time on a cluster for an hour or so, deploy your application, and we host these free clusters in the cloud that you can just run application. We call them party clusters because everyone is in there together, and you just have a chance to kind of have a cluster that you can use without having to set one up yourself. But it's a great place to try out Service Fabric and run things there. So I encourage you to go there.
Sounds like a lot of fun things that people can do after a full day of Connect 2015. Thank you to everybody for joining the panel, joining our panelists and asking some great questions. Have a lot of fun on Azure, and I appreciate your time today. Thank you.